Right. So now we'll start with the introduction part of TEKLA structure. We have just seen the versions. So these are the different versions. And now I will show you the application window. This is the application window, and this part is called the ribbon. Okay. And these are the different
Oh,
tabs in the
okay.
ribbon. These are different tabs. Okay. Wow. So this
Okay.
is called the concrete tab. When you click here, you will see it is highlighted. Okay. So that way
Okay.
we know that this contains only this part. And when you click here, you'll see something is highlighted here. See? Okay, so this will you will understand. Okay, we have to for edit menu, we'll be having this part active. Okay, when I go in the view, you'll see some part is active. So this contents are in the view. All this.
Okay.
So sometimes what happens? No, accidentally you click on this icon here. You see, it says show height. So when I click here accidentally, uh, the view is hidden now. You can see here it is gone. Huh? So when you accidentally click
Okay.
here, it is hide now. So when you want to unhide it, just click here. So you'll be able to see that view icon. Understood? So sometimes it happens that accidentally when we click here, sometimes this happens that accidentally we click on the instead of clicking on the tab, we click on this here, this icon, and then your tab is hidden now. You'll see it is hidden. You can unhide that tab from here. If you want to unhide that, you can click here to unhide. If it is you are not able to understand these, then it is there here also unhide. Okay, so you can hide or unhide that type tab. Okay, this is a tab, and this is called the ribbon. So
Ribbon.
ribbon, yes.
Okay.
Hmm. So there are many
Okay.
different tabs in the ribbon. You can see here: drawing, steel, concrete, edit, view. In views, we it is related to the view or the tools which are related to view manipulation, or we want to do some tools, some navigation is there, zoom, all those things are there which are related to the view part. So we can always use this view. Normally, I will be using new view for creating new view, basic view 2 points. 2 points means it is like a section. You are creating a section. So you can see here, it is like the AutoCAD section we are taking. It is like cutting a section. Okay. And 3 points is 3 points I will not use much, but it is like if it is a bend plate. Okay, bend plate is having three sides, three face. Okay, so if you want to see the view of that bend plate from both the sides in 2D, so you can use this. Use 3 points, but I have not used this much often. Only these two are mostly used, basic view and 2 points. Yeah, these are the most commonly used tools, these two. This is very rarely or not used much.
Okay.
On plane is like, say, this is a plane, work plane. This is a work plane. Red color you are seeing, that is a work plane. And green color is a box, that green box is there. That is a global coordinate system. And whatever is the red, you are seeing in the red, X and Y direction is there. No? So that is called a work plane. And this is called a coordinate system, global coordinate system. Okay, this box means. And this green box is fixed. You cannot move it. Okay, this you can move. You can move this work
Okay.
plane. So work plane can be manipulated using this tool. Okay. From this tool, say 1 point or parallel to XYZ, work plane tool, 2 points, 3 points, and parallel to. These are the available options. Yeah, but anytime we can add some options here also. Through customization, we can add few other options also. These are some basic options they have given, but there are few more options also for view plane. There are, say, I think more than 4 options are there. We can use for setting the work plane, but they have not, TEKLA have not provided all those 8 options here. So only few options are visible. 1, 2, 3, 4, 5. So sorry, 1, 2, 3, 4, 5, 6. These 6 options are there. Other 4 options, yeah, are visible. So you can just see only the 6 options, but when we are going to customize, we can add some more options here in customization. But right now, standard default, you will be having 6 options. Work plane tool, parallel to XYZ, using 1 point, using 2 points, 3 points, and parallel to view plane. Okay? Yeah, parallel to view plane. And then redraw view is also one option. Redraw all view. When I click here, the views will be redrawn. So if say there is some dimension is there like this. For example, now you can see it is not going. So what I will do, I will go into view, redraw all views. So you can see that the dimension is now gone. So whatever dimension is there, if it is still there in the air, say this is the dimension like this. Okay. So, but when I zoom, once the dimension is over, but still you can see the dimension is still there. Hmm. So what I can do, go to view and redraw all views. Okay. So it will automatically remove the temporary dimension. This is temporary dimension. These are the temporary dimensions. Temporary. Just you want to measure something, it will be for a temporary period, and then it once you redraw, it will be gone. Understood?
Okay, understood.
Okay. So and then this is for the work plane. Work plane means you can set work plane for say this is a work plane. This dotted box is there. You can see there are small dots are there. This. And this is one box. We call it as a work plane, work area or work plane. So work area is like will set the boundaries of the model work area. Okay. So we can manipulate that by using 2 points like this. So, but for that we need to go in the plan first, plan view. So I will, for going to into plan view, you have to press Control P. So you can see I'm pressing it from the keyboard. Control, hold the control and press P. And then leave it. Again, hold the control and press P. So it will be moving from plan view to 3D view. Okay. In view also, there is an option here. So whatever shortcut I shown you right now, it is there here also. So plan, plane and 3D. The same thing. Okay, same thing is given here also. And shortcut, keyboard shortcut is Control plus P, Control plus P. That is a keyboard shortcut. I'll just show you on the screen. So what did we just say? Keyboard shortcut. Shortcut for uh, view. View, ready, and plan, plane. Sorry, plane. So what is that shortcut is I used? control plus P. Okay. So that is the shortcut I have used from keyboard. Okay, what?
Okay.
Okay, so this is a shortcut, control plus P, and this is a view property. Whenever I'm going in the some view and double click here, we'll get the view property like this. So whenever I'm going in some object and clicking on that object, you can see when I double click on the object, that particular object property will be displayed to you like this. Okay, what? And this is for creating a view. Say if I want to create a view, basic view, and create. So some view is created. Now you can see there are two views. Okay. Two views are there. One is which is default view. This is created by TEKLA default. And this I have created right now. So view one, by the name you can understand that this is the default view created by TEKLA. And this is a temporary view now.
View.
Why it is temporary? Because it is having a brackets here. Here there is no bracket. So this is the actual view. And this is the temporary view. So when I close this view, now what is temporary view and what is actual view? So when I go in the list here, so whatever is there in the list, that is a actual view. And say this is bracket, no? Now when I remove when I close this, you will only see the 3D. 3D is only there. And when I close this, 3D is already saved here. So this is a saved view. 3D I can always bring back, close, and turn in and turn off. Okay, this way. So this is the actual view, and temporary view is like this. When I create a view, it is not listed here. You can see it is just temporary view because it is having a brackets here. I'll open both the views here like this. And again, one more thing, like here you can see this is 3D. And when I double click here, you'll see there is a bracket here. Start and end, there is a bracket, no? So that is a temporary view. So when I close this, it will not be saved. But yes, we can save it. Say if you want to save this view, you have to remove the bracket. So if I remove the bracket, this view can be saved, but you have to remove that bracket. Now what will happen? This 3D and this 3D, both the names are same, right? Names are same. So when I modify this, it will not update because both the names are same. So I will need to change the name of that view in order to save or make it permanent. So 3D view. So I'm giving it a different name than this one. Now you can see the bracket will be gone. You see here? Bracket is gone and new view is created now. Now when I go here in the list, you see there is listed now. 3D view is now listed. So now I have three views. Sorry, two views. This one is created by me, and this is from the system. Okay, understood?
Yes. Yes.
Okay, so this is the difference between the manually created view and the view generated from the system. The system view is like this. Hope this is clear for you. So
Yes,
I will
clear.
remove the temporary view. Sorry, the view I have created, I will remove that. And I will keep the 3D view, which is from the system. Okay. Sometimes we need a 3D view at some different levels. So that time we are using this basic view creation. Right? Now this basic view is on the 0 level. Coordinate is 0. So XY, plane is XY, coordinate is 0. XY plane means that will be a plan view. And coordinate is, so if it is a XY plane, so the coordinate will be Z. This will be Z. You can see when I pull down the menu, you will see XZ. If it is X and Z, means I'm talking about this plane. And the coordinate will be Y. Okay, I'll show you what happens. What is the meaning of that? Say if this is the XY plane and I want to create a view 100 meters. So this is 100 meters, okay? 100 and 1000 I have added. So this is 100 meters total. 1 lakh mm. Okay, when I create a view, you see there is nothing here. There is no grid here. So what will I do? I will create a new grid. Grid. And then I will add here 100 meter. And then create. Now you can see there is a grid here now on 100 meters. Okay. When you see this 100 meters from 0, which is a 0, is 100 meters. And when I see here, here I will see the 0 level grids. These are the 0 level grids. And this is a 100 level grid. So there are two different grids. So when I go here, I will need to change this to 3D view, add 100 meters. So I will keep it as meters. So when I go in the view, I can see there are two views now. One is at 3D 0 and this is 100 meters. 100 meters. Okay, you understood this part?
Yeah. Yes.
So this is just a basic idea of how view are generated. This is very, very basic thing. And generally in a company, when you go in any company, no, that time many people will trouble, will be having trouble understanding this part
Uh-huh.
because they have not cleared, means this part will not be clear in their TEKLA training maybe. So
Mhm.
normally in TEKLA training, what happens? They will give you training on the zero view from zero coordinate system. But they will not tell you about how the 100-meter level is created. Okay. So this is how the 100-meter level will be created. Okay. This way. So many times, no, pressure will be getting confused how they have to create a 100-meter level. So these are two different grids. Okay. This is on zero level, and this is on
100.
this 100 meter.
100.
100 means this is actually starting 1 lakh. 1 lakh mm. Mm.
Yeah. Right.
Okay. 1 lakh mm. So that is will be your 100-meter level. So that way we need to create. So here now, this levels, say this is 5,000. Sorry, 5,000. Then 10,000. 20,000. Say like this level is there. So your zero is actually, what is this? 100. 100.00. And your next level will be, so 100 plus 5,000. So what, how much it will be? 100.500. Okay. 100 plus 10,000 will be 100 point, sorry, 100, 101. Oh, sorry, I'm sorry. 105.00. And this will be 1110, right? 10,000 is added in one level. And then plus 120.001. Did you got this? I will write as meter. Here I will write as a meter. So that whoever looks at the grid will understand. Okay, this is a meter. Meter. That way, somebody who is working at this level, he will understand. Okay, this is in meters. Okay, so I have converted it in meter. Here it is in mm. But the level, actual level is 100 meter. Here. Okay, so this is the actual level. So in drawing, when I create a drawing, there will be a level will be according to this level. There is a way we can change it to 0 also. So 100 can be 100 meters can be converted to 0 also. So you can keep this as 0 also. But if the requirement is there, like what happens normally, no? Say 100-meter level is there for a pipe. So when we are exporting it in some other software, so what is the requirement that they need 100-meter level in that model? But when we are working on the drawing, that time we need to start it from 0. 0 plus 5,000 plus 20,000. उठलो ना मी तो जाम बरेच नाही फक्त उठवायला लावू नको मला याची. Okay, so if it is 100 meters, so I can show this in drawing. So whenever I'm opening a drawing, you will see these levels will be inside the drawings. All these levels. So this will be reflecting in the drawing part. And this labels will be also available in the drawing. Okay. 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 So this is how we will be creating a grid from different levels actually. It's like different level when there are different level, how we can add the level difference in that. So if it is a 0 level, then this is a normal procedure for adding a grid. If it is your model is in 0 level, this is normally how will you go in the model. But in case if you have different levels, then you have to add it from here like this. Also, there is another different method is like you can keep this as 0 and here you can change the level to 100 actual level 100 and this is actual level 100. Okay, so I can give the actual figures now. Okay, this is also okay. This is also correct way. Okay, so when I modify here, it should not be 0 here. I will modify it. Modify. This will work. Okay. This will also work. And if you are giving it 0, that will work. This is actual level. This is actual level. And if you are providing it from 0, then you have to change this origin. Okay, so origin is kept 0. Now what I have done is I have kept the origin at 0. So origin is here only 0, 0, 0. So that is somewhere here. And so 0 level is here. 0 level is here. And your 100 level will be here. So there is two ways. Now I have shown you two ways to do it. If it is 0, then here 0 you have to remove and then add the actual levels here. Okay, so this is one way. This will remain same. This should be matching here. You have to keep this
Okay.
according to the Z level. Only change will
Z
be,
level.
the only change will be this one. So if I am starting this from 0, then I have to change here
Second level.
Z coordinate. So this will be 0 and then 5,000, 10,000, 20,000. Okay. Both these options will give you, the result will be same. Okay, but the way of working is different. Okay. Did you understood?
Yeah. Yes.
Okay. So both the options I have shown you for placing the grid. So this is only used when the grid levels are above 0, or the starting point of the building is 100 meters above. Okay, somewhere top. So your building will not start from 0. At that time, you have to work out in this way, the origin. Okay. If your the coordinate system is starting from 0, that's fine. Then you can use this one, standard procedure. This is a standard procedure. Then you don't need to create a this 1,000-meter grid. Okay, for standard procedure, I will remove this. I will keep the standard procedure. So this is like standard from 0 to 5,000, then 10,000, 20,000. And here actual levels will be there now, 5,000. So this will be 5.000 plus 10.000 plus 20. These are the actual levels. Okay. Starting from 0. The model is starting from 0 is this way. So when we are in the training models, we'll be starting it like this. Okay, grids. Did you understood?
Yeah.
So the other thing I shown you, that is for a different way, when there is a different requirement, mostly for 100 meters. If the model is on 100 meters, then you have to go for that option. Right? This is a standard procedure. And then view, we have seen different views we can create from here. On plane, on part. There are many ways you can try this out. Once we have TEKLA, you can work out on those different options. Okay. But most commonly we'll be using basic view and two views. This is most commonly used.
Oh.
Okay. And work plane also,
Okay.
if I want to fit the objects, then I'll be using this option. Fit work area to entire model. That way, it will fit the entire work area. What has happened? That 3D grid is there in the top. So I have to remove that grid. So again, I have to create a basic view there and then delete this grid. I don't need that grid. And then now you can see this view is enlarged, no? Work area. Now I will say fit work area. Now you can see that grid is gone now. So now my work area is reduced. Okay. So when I want to add a grid, I will simply add it from the origin. So 0, 0, 0, and then whatever is on the x directions. So here you have to give the x coordinates, here y coordinates. So when you look at the coordinate system, then you will understand, okay, these are the coordinate systems. And x direction is on this side, y direction on this side.
Yeah.
So that way you have to add this spacings.
Spacing.
Spacing. Yeah, these are the spacing between these grids.
Distant.
So this is now 5 into 6,000. So 1, 2, 3, 4, and 5. Okay, if I want to give a deferred spacing, then 6,000,
6,000.
8,000, 7,500. Say the spacing is different. Okay, for example, I can give it like this also. If your drawing is having like the spacing, then I can give this kind of spacing also, like this. Okay. So this is just an example. What TEKLA is there, you can give actual as per your requirement. So whatever your project requirement is, so the columns offset normally in the building, this spacing will be according to your column offset. So center distance. So whatever is mentioned in your design drawing, say one column to one column offset is 8,000. So I have given here 8,000. First, this column to this column is 6,000. So here there is 6,000. Again, from this column to this column is 8,000. That's why I have given here 8,000. Okay. Again, here there is a different spacing. So we can work out like how our columns are there. According to that, we can place the grids. You can manipulate this. Okay, according to your building dimensions. So for this, normally you will be having a design drawing. Just open up some design drawing, sample design drawing, which we will be using for our lectures. I'll share you with this design drawing. Okay, this is like a sample design drawing which you are seeing right now. You might have seen already the civil design drawing structural. It will look something like this when you open any civil design drawing, structural, steel structural design drawing, or the engineering drawing. It will look somewhat like this. So this is just a sample, and we will be using this sample for our training next sessions. Okay, what? I think you are already done this kind of work before. Or not?
What's that?
You are aware of this kind of drawings?
But I cannot learn more. You know,
Okay, okay. Okay.
I just
So,
could say that.
you are seeing it for first time.
Yeah.
Okay, okay. So this is like a engineering drawing, which we'll be using for modeling our 3D models. Okay. So there will be information given on this. This we call it as a design drawing. Okay. In project life cycle, I have shown you earlier. Project life cycle. Here I have shown you what happens in the project life cycle. Here I have shown you the starting point is there, and the designer will be providing us with the design data. Design data. So what design data looks like this? Okay. This is the design data, which is contains member sizes. Different member sizes will be there here. You can see different member sizes will be listed here. HEA 600, HEA 650. So when I go in TEKLA, you will be having these member sizes here. When I go in the beam, here profile. Okay, here you will see the different member sizes will be there. So whatever you see in this standard engineering drawing, same thing will be there in the TEKLA library. But you have to open the right environment. So now this is the default environment. So I'm able to see HEA. If I want to HEA, yeah, if I want to use some different, like here there is a different standard, for example. I will show you the next sheet. Now here I have added a example of US standard, US W14. So when I go here, you will not find the W14 here because That is a different standard, different country standard. So US is a different country and it is having a very different standard. So this profile you will not get in